Hello everyone. I am currently working on a multiplayer game that I'm going to put on Steam, and I've been wanting to get a stylized, cartoonish look for the game. And after about a month, I think I finally landed on something that I really like, and I wanted to share it with other people so they can build upon what I've created and hopefully create something cool for themselves. Because I've seen a lot of tutorials online for how to create your own stylized shaders, but they're not super great per se, and not saying that mine's going to be amazing, but I'm going to try to keep things simple and quick, and hopefully you guys can get things figured out. So first off, I'm going to be using Unity version 6000.032F1 for this project, and I'm going to be creating a universal 3D project here, just from scratch. I'm going to show you exactly how to get this set up from a brand new project. So I'm just going to call this example project for vid. And we're going to create the project. Now, while this is loading, you will, in the description of this video, find a link to a Unity package called Retro Rendering. And this is going to contain the shader that I created and the custom render feature that I made that you will need to make this work. So please make sure that you go to that link and download this, or you're going to be confused. Or I guess you could just code it from scratch if you want to, but either way, you're going to have the same thing. And again, I do want to preface that I am still very new to shaders. I am by no means a professional. I'm still learning. So I'm sure there are ways that I did this that are maybe stupid, but that's okay. Part of the reason I'm putting this online is I hope other people can edit it and improve it themselves. And if you guys do, I'd love to hear what changes you made in the comments below. Oh my gosh, we made it. Okay, so this is just a brand new Unity project. I'm gonna go ahead and delete this README file. Maybe, there we go. And ignore whatever that error is. It's probably fine. Go away. And what we're going to do first is right-click in our assets and click on Import Package. We're going to click Custom Package, and then we are going to navigate to the one that we downloaded from the link in the description. So Retro Rendering, and click Open. Now in here you're going to see it includes the custom render feature script and the shader, and we're going to click Import. Now the shader script is called Pixelation V2 because originally I was trying to make a script that could like pixelize the image, but you could rename the shader to something else if you want. Now after you import that in, it should go pretty quick. You'll have this scripts folder in your assets, and then under that will be a post-processing folder, and under that will be our custom render feature script. And then in our shaders folder, we will have this Pixelation V2 shader. Now, I'm going to open this up, and I'm not going to explain every little bit of what this is doing, because I had to learn almost like a whole new programming language to figure out how the heck this all works. But I'll kind of do a broad summary of how it works. And where am I going? There we go. Scripts, post-processing, custom render feature. So essentially, what I did is I had a few options. I looked into trying to create like a override for the global volume here and put the settings within that, but I had some issues there. So what I actually decided to do was create my own custom render feature. And this allows us to essentially change how our game is rendered and how our camera views things with each render pass, which is super cool. So what you're going to need to do first is right-click in your assets, go to Create, Rendering, and what we want to do is create a URP Universal Renderer. And again, I am using URP, the Universal Render Pipeline, for this. And I'm just going to name this My Renderer. There we go. And we're essentially going to be replacing the default renderer that Unity uses with our own custom renderer. So to do that, we're going to go into Edit, Project Settings. We're going to navigate to this Graphics tab over here. And you'll notice here that we have this default render pipeline. If we double click on this right here, and then we bring this window down, you can see that it highlighted this PC_RP asset. And we have this universal render data here. And we can see here that this is the default PC renderer that it's using. So what we want to do is change what renderer we're using right here. So instead of using this default PC renderer, I'm going to go ahead and lock the inspector here. I'm going to go to my assets, and I'm going to drag in my new renderer here. And now we're going to be using our custom renderer, which right now it doesn't do anything different. It basically just does the same thing. It's the default, right? But we can do something cool with it. So if we click on my renderer here and unlock this, we can see here that we have some different options here, and we can add a render feature. Now, normally here you would just have these, but we have our own custom render feature, which is appearing right here. And this is our script right here. And this custom render feature script is a C# script that derives from the scriptable render feature class, which is what allows us to do fun, fancy things and actually connect our render feature to our shader. So clicking back on my renderer here in the assets, one thing I'm going to do is click Add Render Feature, and we're going to select our custom render feature. Now that we've done that, this is the fun part. We're going to hit the drop down and hit the drop down for settings. I've never messed with the name here before. I've just always kept it the same. But now we can actually see the custom render feature and shader that I've been working on for like a month. And again, it's not perfect, but it does some really powerful things. Now, there's one problem though. Messing with these sliders, nothing is really happening right now. Like this resolution scale should make the game more pixelated. First thing we need to do is we need to click main camera and make sure post-processing is on, which it is. And if it is on and you're still not seeing any effects, what we need to do is we can see here that for our post-processing, there's this post-processing data. And if we click this, we can find that in our assets here. We're going to actually create our own post-process data. So I'm going to right-click on my renderer here. I'm going to go to Create, Rendering, URP Post-Process Data. And I'll just say my post-process data. There we go. And let's go ahead and just assign this to our renderer. And you can see that nothing happened because I'm a fucking idiot. Okay, so the reason we still can't see anything is because there is this error that you can get where it says the render pass custom render feature pass does not have an implemented blah blah blah, don't care. It says we can fix it by going to Edit, Project Settings, Graphics, URP. And we need to turn on compatibility mode. So Edit, Project Settings, Graphics, and then we need to, where is it? And then we need to scroll down to the bottom here and turn on compatibility mode, render graph disabled. This has to do, it says Unity no longer develops or improves the rendering path that does not use Render Graph API. Use the Render Graph API when developing new graphic features, which I don't care. Okay, real quick, this is Future Harrison talking. Down here at the bottom in this render pass event, I forgot to mention that I also went and clicked after rendering. This basically changes when we apply our effects, and by default it's before rendering transparency, but make sure that this is selected as after rendering. We need to make sure that's where that is. And there we go. Now that we've done that, we can see horrible things are happening because I was tinkering with settings to see if this was working. Let me just turn everything off and explain what each thing does one by one so you know how to properly make this work with your project. So first off is the resolution scale, palette size, and color shift. Now, first off, let's bring up the resolution scale and palette size so we can see what's happening. Now, I don't know why this is happening, but for whatever reason, and this doesn't happen on my original project, but it flips the camera. But if you turn resolution scale to 0, it doesn't. So I'm not sure why that's happening. You could probably fix this in the shader by inverting the UVs here, but also we can just do this. Wait, wrong axis. We can just do this. So I'm gonna rotate the camera 180 degrees on the Z axis because that works too, and that fixes it, and I don't feel like changing the code, but if anyone figures that out, let me know. So anyway, we've rotated our camera now, and we have our cube here. And back on the My Renderer asset, we can adjust our resolution scale now. And you can see that we can make it really low to make our game super pixelated, or higher, which is cool. So I'm going to bring it down to, we'll do like 1.15. And I'm going to actually get rid of this directional light. And I'm going to just add a plane in here, just for the sake of showing everything off. And let's go to a light, add a point light. This is basically what I did for the thumbnail. And we can use this to kind of test things. Yeah, there we go. Cool. And let's increase the intensity of this point light. Perfect. So this will be good for testing our shadows and our lighting. So here I can change, like I mentioned, the resolution scale. So yeah, that's about fine there. And the palette size actually allows us to choose the bit rate of our game, meaning how many color channels it can use. So if I put it at 16 bits, that means it can only use 16 colors. If I put it at 8 bits, it can only use 8 colors. And I can go all the way up to 256, which is the maximum. And you can go all the way down to 2, which doesn't look very good, because it can only use 2 colors. But you can use this to create a really cool retro style game. But if you don't want the retro style, then you don't need to mess with the resolution scale or the palette size at all. But I think it looks quite cool. So I'll put that at like 40. I also do have this color shift, which if we bring it up really high, you can see it overlays a bunch of different intense color variations of the original image. And the reason I did this is because if you just increase it by a little bit, you can create this cool little outline effect. And I think that looks pretty awesome. There's also just a simple color filter here. It doesn't really do anything special aside apply a color filter, but you can do that in plenty of other ways. I just figured I'd add it. Now, this is where we get into the fun stuff, which is textured shadows and lighting. And this is what I had the most fun doing, and was what was also the biggest pain in the butt. But if I increase this shadow scanline intensity, you can see nothing's happening because there are no dark pixel threshold. There's no dark pixel threshold value. And the dark pixel threshold value determines how dark the pixel has to be for this texture to be applied on it. So we can adjust this dark pixel threshold here, and the higher it goes, the more, or the lighter the pixel can be to include the scanline. The lower it is, the darker the pixel will have to be to overlay the texture on it. So I'm going to put it at about 1.27 or 5, just because that's bothering me. And I'm going to increase the shadow scanline frequency, which is going to add more scanlines. So we'll do, let's say, 70. Whoa, we'll do 70. And we can also increase and decrease the intensity of these scan lines. So I'll do about 70%, so 0.7. And lastly, we can change the direction ID. If we leave it at 0, it's just horizontal. If we bring it to 1 or higher, it's going to be vertical. And 2 is going to be cross-hatching. And again, it isn't perfect, but feel free to adjust it and see if you guys can find your own way of making these scan lines cooler. This is just to get you started. And it works well for my game. So the next thing, and this is what I'm most proud of, is the highlight dot effect. So this actually allows us to add a dotted textured pattern to our lighter pixels in our scene. So if I increase this light pixel threshold, you'll also see that nothing happens because it's basically the same as this dark pixel threshold here. So we need to increase the dot density and the dot radius. And let's actually bring this threshold down just so we can get these to appear. There we go. Needed to increase the radius a little bit. And then we also have a brightness boost here. And I'm actually going to turn the resolution up so it's more obvious what's happening. So I'm going to put it all the way up because the pixelation kind of makes it look weird. But you can see when we change the light pixel threshold, it changes how bright the pixel has to be for this light, these lighter dots to be applied to it. So I'm going to put it about there, and then we can increase the dot density, which is like the tiling of the dot's texture. So maybe I'll do something like this just for now. And we can change the dot radius as well. So maybe something like that. And then there's just an overall brightness boost that you can apply to your dots, just to tinker with it. You can also change the color of the dots, which is pretty cool, and you can get some cool effects with that. Put the palette size at like 35 for this. And the cool thing about this is it kind of looks weird in the scene view, which is why I have the game view up here. But the cool thing about this is I can move around this point light and it will dynamically change, and my custom render feature and shader will update with everything, which is really awesome. So this is just something I wanted to share with you guys, and I hope that you're able to expand and build upon this and make it better, because this is still in very early stages of development. But I thought that I'd share it, so hopefully you guys can mess around with this and make it look good for your game and maybe find some new things. Now back in the code here, I'm not going to go super in-depth into how everything works, but just to give you some general organization here, this is how we can set up our UVs, which is why I mentioned maybe trying to flip the UVs right here instead might work. And then this is allowing us to change our palette size for the different colors that we're using. This actually applies our scan line effect, and I did this with a horrible switch statement to determine if we're going to have the scan lines go sideways or horizontal, vertical, and if there's going to be both for cross-hatching. And then this half-for frag function is what actually applies the color changes and different things to each of the pixels. And there's a lot of stuff going on in here. But you can see here that we have this if statement here detecting if the pixel is lighter than the light pixel threshold, and same for if the brightness is darker than the dark pixel threshold, so we know where to apply our dots to and where to apply our scan lines to. And the scan lines can also be a cool effect to get a retro look if you just want to apply them to your entire image. So you could just bring the dark pixel threshold up here and just apply the scan lines to the entire thing, kind of like an old TV. So if you want to just use it for that, you absolutely could do that too. And so I hope you guys are able to expand upon this. If you have any questions, just let me know in the comments below if things aren't working. And just so you're aware, for the custom render feature, if you do want to add your own settings that you can change, you would add them in here like you normally would. And again, if you are actually going to mess with the shader, I recommend doing some research and watching some other tutorials on YouTube for how shaders are structured and how to actually program with them, because that is a whole nother video, and this is not about that. This is just about setting up this pre-existing system. But you could create your own variable here. So maybe I'd create one for like a cartoon outline. So maybe I'd call it cartoon outline intensity. And then what you need to do is in your custom render feature, you would need to add a float into here. So public float, because this is what actually is referenced in the editor and what we're able to change. These are the actual values we're changing. They're just being linked to the shader. And by default, set this equal to 0.5. And then what you would need to do is in here, you would need to say material.setFloat and then get the name of the variable in the shader, which is underscore cartoon outline intensity. So copy and paste that in there. And then get the setting we want to attach it to, which is the cartoon outline intensity up here under our custom render feature settings. So I would just paste that in. And then those variables are linked up. And of course, you would also have to add it under your C program here. So you do float underscore cartoon outline intensity. And again, a lot of this won't make sense if you're not into shaders, but if you want to go that far and start implementing your own stuff, and if you already know how shaders work, this will make sense. But that's how you connect everything. So if you did that, don't mind the pink screen, and go back into here, it will then link up all of the variables. And it's really mad at me right now. Sometimes too, if you're having tons of issues and it says some weird thing, error, like it couldn't find certain keywords, you have to just reload Unity. I don't know why. Working with shaders, it's like super touchy and sensitive. Like sometimes you'll just go in and change one little thing and then it will break and you just have to like reload the project. So it's really weird. I don't know why shaders are so touchy, probably because you're modifying the different draw calls to your graphics card, but sometimes giving Unity a good old restart will solve your problem. So if you start messing with it, just something to know. And there we go. Yeah, it fixed the issue I was having. But anyway, you can see now we have this cartoon outline intensity slider here that I added. It doesn't do anything, of course. This is just an example. And by the way, if you'd like another video on how to do cartoon outlines, let me know. I did that in my game, but I didn't do it within this shader and render feature here because I think it's better to do it per object as a shader material that you apply to it, so that way it actually knows the shape of the object and where the outline should be. But anyway, I'm going to remove this cartoon outline intensity from here because I don't need it. It was just an example, so we're just going to get rid of that. That's how you could start by adding your own variables in if you wanted to. So we're going to save these. I hope you found this video helpful. Again, let me know if you need any help in the comments below, and thank you for watching. Consider subscribing.